a video tutorial on how to solve for simultaneous linear equations. The goal of solving for these equations is we're trying to find a value for each variable that satisfy both equations. And what I mean by satisfy both equations is when you plug the values you find back into either equation, the equation is balanced. So the left-hand side equals the right-hand side, or when you work it all the way down, 0 will equal 0. How we go about doing that is we're going to add these two equations together to cancel one of the expressions with one of the variables. So if, for instance, if I multiply this bottom equation by -4, this is going to give us an expression with the x that is going to cancel with the corresponding expression in the equation above. Okay, so rewriting the first equation, 4x plus 3y equals 10. Now, this is just an equation, so we can do whatever we want to the equation as long as we apply the same mathematical operation on both sides. The previous video I kind of go into why that is and different ways in which you can do it. So in this situation we're going to multiply each side by a value of -4. So let's write that explicitly. So -4 by x is -4x, y by -4 is -4y, 3 by -4 equals -12. Now what we're going to do is we're going to add these two equations together. So we can see that 4x minus 4x is going to cross to give us 0. Then we're left with a 3y minus a 4y is equal to -y. And then we have a 10 and a -12, which will give us -2. Now we always like to have the variable positive, so we're just going to multiply each side by a -1, which then will give us y equals 2. Okay, great. So we found the first variable, the value of the first variable. Now it's very straightforward to find the other variable. What we do is we just pick one of the equations, insert that value in, and then work through and solve for the value of the other variable. So because the second equation is more simple, we'll just use that one. So taking x, and we have a plus y. Now we found y to be equal to 2, so all we have to do is put in 2. That is equal to 3. So then working through this, we know that x is equal, we're going to -2 from both sides, which is going to give us a 3 minus 2, which will give us 1. So we have x equals 1, y equals 2. So essentially, if you were to plug these two values back into these two equations, the equation will be balanced, and that's how you verify if you're correct or not. Taking the same approach, okay, so there's many ways to do it, but you obviously want to look for the most simple one because you don't want to apply some crazy operation that just makes it more complicated than it needs to be. So for me anyway, the first thing that pops into mind is we have an e and a 5e. So I know if I multiply that e by a -5, we're going to get a -5e, a 5e, which will give us 0. So I'm going to multiply the top equation by -5. So that's going to give us -5e, a -3f by -5 is going to give us a plus 15f. -5 by -5 is plus 25 equals 0. And now we just rewrite the equation we didn't edit. Okay, so now we're just going to add them together. So we have a -5e plus 5e cancels to give us 0. That's good news. 15f minus f, we're left with 14f, and then we're going to have 25 plus 17 is going to give us a positive 42 equals 0. Alright, so now we just want to have the expressions with variables to one side, numbers to the other. So we're going to take away 42 from both sides. That'll leave us with a 14f equals -42. And then dividing each side by 14, that's going to give us an f value of -3. and then plugging that back in, we'll use the first equation because it's a little bit more simple. We're going to have e minus 3, and we know that f is minus 3, so we just plug that in. We have a minus 5 equals to 0. Tidying that up, we have an e. This is going to be a positive 9 minus 5, so 9 minus 5 will give us 4, and then we're going to minus 4 from both sides, so e is going to be equal to minus 4. So we have f equals to minus 3, e equals to minus 4. If you want to verify you're correct, plug an f value, the e value, into both of these equations, and you'll find that the equation will be balanced. The third example is the most difficult for obvious reasons initially, that it has fractions. So what we want to do is firstly get rid of them fractions so that we can follow the procedure we've done for the other two examples. So we have the same divisor on this side here. So we have a 5 over 4, a 3 over 4. Now in order to cancel them two 4s, what we would do is we would multiply the equation by 4, because if we have a 4 up top, they'll cancel, just leaving the integer values. So we're going to multiply that by positive 4. That's going to leave us with a 4 up here, going to leave us with a 4 here, and then this is going to leave us with a 12 here. Alright, so we have a 4 here, we have a 4 up top, we have a 4 at the bottom, so they're going to cancel, and that's just going to leave us with a 5x. We have a 4 up top here, that's going to cancel, the 4 at the bottom, and that's just going to leave us with a minus 3y, and then 3 by 4 is 12. So now if I write this out, the second equation now looks something a lot more similar to what we have over here. So then the second thing that we would do now is we want to find these operations that let us cross out one of the variables, such as the examples over here. Now you can see that it's not as straightforward at first glance. So what you might have to do, instead of operating just on one equation, you might have to operate on both equations to get that same crossing out. So for me, what comes to mind first is I'm just going to choose the y's. So I want to get rid of the y's. So what I'm going to do is multiply the top by 2, but I'm going to multiply the bottom by 3. Okay, so by 3. Let's do that. So that's going to be 10x plus 6y equals 24. The bottom is going to be 3 by 3, that's going to be 9x plus 6y, oh sorry, my mistake, 2 by minus 3 is minus 6, and then equal to 33. Okay, so we've now got the same template as over here. We can get rid of the two 6's, and that has left us with a 19x equals 24 plus 33 is 57. Then we divide both sides by 19, and that x is equal to 3. Okay, so now to find the y value, I'll just box this off because it might get... Alright, so let's pick the first equation. We have a 3, and we know that x is 3. And then we have a plus 2y, and we have an equals 11. So we know that 3 by 3 is 9, and then we're going to minus that 9 from this side, minus it from this side, so that's going to give us a 2y equals 11 minus 9 is 2. Divide by 2 on both sides. So that's an introduction on how to solve simultaneous linear equations with two variables. I'm going to do examples with 3 variables, so saying x, y, z and a, b, c It's the same procedure, a little bit more complicated, but once you get used to the linear equations, it's not a hard jump up to the linear equations with more than two variables. So I hope you enjoyed the video. If you enjoyed it, learned something from it, then subscribing would be great, because it's a new channel, and also I'll be doing a full course on algebra. If you want to start from the beginning, if you're brand new to algebra, I've gone from step 1 and I'm working my way up. So if you get something from it, like and subscribe, and yeah, hope you enjoyed. Thanks.